Good day to Inje Muhammad Hairul and Dr. Noor Aslina. My name is CHOO SHEN WEI, and the title of my final year project is The Strength of Formed Concrete Filled Hollow Section Added Steel Fibre Under CYCLIC by Using Finite Element Method. For the introduction part, concrete filled steel hollow sections are widely used in the construction industry for these past few years. Cycle loading is the application of repeated stresses, stress or strain intensity to location on structural components. The finite element method is a numerical technique used to solve engineering problems. ANSYS create stimulated computer model of structure, electronic or machine component to stimulate strength. For the problem statement, the first problem is lacking information of material properties from the previous experimental result did by Ahmad Luqman. Furthermore, there are many uncertain properties values such as shear transfer coefficient and meshing size. The cost of doing laboratory experiment has increased and occupied a lot of time. The use of the software ANSYS can help in reducing the cost and time consuming on experimental specimens. For the objectives, the first objective is to determine the strength and ductility of formed concrete filled hollow section under cyclic load by using finite element software. Second is to validate the finite element analysis and previous experimental result. For the scope of study, this research is to identify the value obtained by using finite element method in terms of ductility and resistance ratio of concrete filled hollow section using formed concrete with the adding of steel fiber while comparing to experimental result of previous study. To achieve the objective of this research, the experimental result carried out by Ahmad Luqman is used as the reference in this research. For the significance of the study, first is to promote formed concrete as a lightweight concrete can be used in building construction. Second is to promote the software ANSYS of finite element method can be replaced the traditional laboratory work. For literature review part, a lot of article is used as reference in this study. Some of these articles is shown as slide above. For the methodology part, the first part is to defining the element type and the material properties. First is to generate the geometry of the model. Then is the processing of meshing size. Then is the setup for cycle time. Then is the selection of stress parameter for solution. And lastly is the result output. Next, I will be showing how I did my modeling in ANSYS. The first step is to generate the size of column, and the geometry of column is generated out and drawn as slide above. Then is to input the material properties of the solid by using command ATPL as above. These material properties will refer to Ahmad Luqman's previous experimental result. This is how material properties will display in the mechanical ATPL. After that is to set the pin-pin connection at the top and bottom of the column. The remote displacement is set at top and bottom of the column. The remote displacement is then insert the value as the graph shown as slide above with the frequency of 0.25 Hz and using 10 cycle, and the amplitude of the displacement applied in this modeling is 3 mm, which is taken from the range applied in ECCS 1986. After that is to set the contact surface for solid to solid, which is the steel to the concrete surface. After that is to determine the meshing size. The meshing size I used was 5 mm. The meshing properties I used was tetrahedron 5 mm. This is how column will behave when undergo cyclic load in this ANSYS modeling. The first graph shown is hysteretic loop of concrete filled hollow section with formed concrete, added steel fiber and dry hard edge. Only one complete 3 mm displacement graph is selected to calculate the ductility. Next is the hysteretic loop of concrete filled hollow section with formed concrete and raised hard edge. A complete 3 mm displacement graph is selected to calculate the ductility. Next is the hysteretic loop of structural steel hollow section. By using the same way, one complete 3 mm displacement cycle is selected to calculate the ductility. This is how the graph pattern by previous study on ECCS 1986. It can be proved that the graph generated from ANSYS have a very high similarity with previous experimental result. For the result part, these are the formula to calculate partial ductility, full ductility ratio, and the last is the resistance ratio. The displacement and yield strength of 3 types of material is obtained from FE curve by referring to ECCS 1986. By using the formula provided by ECCS 1986, the value of partially ductility, full ductility ratio, and resistance ratio has shown in the top graph, while the graph below is the value, while the bottom table is the experimental result carried out by Ahmad Luqman previous study. After that is the comparison of modeling output and the experimental result did by Ahmad Luqman. The first comparison is the comparison of partially ductility. From the table above, you can show that the 3 models which are unfilled hollow section, form concrete filled hollow section with dry harsh edge, and form concrete filled hollow section with steel fiber and dry harsh edge has the low discrepancy which are lower than 20%. Next, for the comparison of full ductility, the discrepancy of 3 models are around 20%. Next, for the comparison of full ductility ratio, the discrepancy is shown as table above. And lastly, for the comparison of resistance ratio, based on the comparison of resistance ratio in the table above, all these 3 models having the huge discrepancy which considered not acceptable in this study. This may due to the lacking information of stress strain curve from the previous experiment by Ahmad Luqman. For the conclusion part, the ductility of the modeling column under cyclic load could be determined by using finite element method. Finite element method show a very similar pattern of graph when comparing to the graph of ECCS 1986. Partially ductility, full ductility ratio, and resistance ratio were used as the comparison result in this study. The partially ductility, full ductility, and full ductility ratio show a great agreement which is having the discrepancy less than 20%, while the resistance ratio show a very poor agreement which is having a huge value of discrepancy more than 100%. These are some of the reference shown in slide above. That's all for me. Thank you.